Namaskar. I hope you are in best of your health and enjoying your studies at the moment. So today we are going to solve another question from partial differential equation. It's an important question but a easy one to solve. So for this type of question just have to make some assumption. So how to go ahead with this problem? We just make an small assumption. You can see that we have del 2z by del x square. That means the second partial derivative with respect to x. As you all know that z is a function of x and y. That's why we use the concept of partial derivative. But if we make an assumption that z is only a function of x, then we can switch from this partial differential world to the ordinary differential world, and that is easy to solve. So we'll make that assumption. So let z be a function of x only. And when you make this assumption, now we can write, instead of del, we can simply write in terms of d, and our equation will now convert to d2z divided by dx square plus z equals to 0. Now it's quite easy to solve. We know that d2 by dx square can be written as d square, and also currently z is your dependent variable and x is your independent variable. Throughout this problem, when you will solve through ODE, you will have to keep in mind that z is your dependent variable and x is your independent variable. So this can be written as d2 plus 1 operating on z equals to 0. Now we'll solve this. You know the method how to solve it. RHS is 0, so there will be no particular integral, and as and when it comes to your complementary function, so because the independent variable is x, this can be written as first of all, for that we need auxiliary equation as well. So let's first find our auxiliary equation, which will be your auxiliary equation will be m square plus 1 equals to 0. So from here you are getting m square as minus 1. So m will be plus and minus iota. So because m is plus minus iota, that we can write this as m1 is 0 plus iota and m2 as 0 minus iota. We can write our complementary function as e power, if this is a plus ib and a minus ib format, so e power ax, a is 0, so e power 0x. I am using the constant as a and b, so a cos bx, b here is 1, so simply a cos x. The second constant, as I mentioned, I'm going to use as b, so b sin x. B here is 1, a here is small a and small b. If you talk about the small a here is 0 and the small b here is 1. So this is it. Now because your particular integral is 0, because the RHS is 0, I can finally write your dependent variable, which is z, to be equal to e power 0x is 1. So this can simply be written as a cos x plus b sin x. b sin x. Now we had made an assumption that z is a function of x only, but this is not the case. Z is function of both x and y. So now we will make our correction in this. So what we will say here, that but z is a function of both x and y. So what we'll do, because z is a function of both x and y, you can see currently z is a function of x. So how to make a function of y also? You are seeing two constant a and b, so we can, if we replace that by a function of y, then this will become both function of x and y. So what I will do, I will assume now or say that capital A to be a function of y. So let's name that f of y, and the other constant which is there b to be g of y. Now everything is sorted, because now your whatever you will write, which I will write in the next step, which is your z. So your z will be, your z now will be, in place of a write f of y cos x, in place of b write g of y, and then you have a sine x. Okay, now we'll come to the condition. This is what we have got. You can name this as some equation number, let's say 1. Now using the condition, the first condition is your x equals to 0, then z equals to e power y. So when I take z as e power y, if you take x as 0, cos 0 is 1 and sine 0 is 0, so second term completely vanishes. So you are left with f of y, and cos 0 is 1. So you have now got the value of, easily got the value of f of y. Now using the second condition, but for the second condition we have to find del z by del x. So let's find that. So del z by del x, what will it be? Because we are doing partial derivative with respect to x, so y will be treated as constant. Derivative of cos x is minus sin x, so minus f of y sin x. Derivative of sine is cos, so plus g of y cos x. Now again use the condition, when x equals to 0, del z by del x is 1. So 1 equals to, again if you see, when you put x as 0, the first term again completely vanishes. What about second term? Second term again cos 0 is 1, so you are left with g of y. So you have got the value of g of y to be 1, f of y to be e power y. So if I substitute this value back into my equation number 1, so my equation number 1, f of y to be replaced by e power y, g of y to be replaced by 1. So I will get z equals to e power y cos x plus sin x. So let's write this in the top. So my final solution is z equals to e power y in place of fy, so e power y cos x, plus in place of g power y we simply write 1, so plus sine of x. So this is going to be your final answer for this particular question. I hope you understood it. The first assumption was, let's take z to be a function of x only. In that case we came to the ordinary differential world. We'll solve it using the particular integral complementary function. Simply no problem was there. So we got z, but z is a function of both x and y, so a was f of y and b was g of y. Then we used both the condition in order to find the value of f of y, g of y, put that back into the equation and get your final answer. So I hope you understood it. Thanks and have a very nice day.